We'll talk about week 6 on DAC first, digital to analog system first. Okay, so these things are pretty much important. So in decimal base 10, you're gonna know how to translate from this thing back to this thing or whatsoever. So if you translate 1206 into base 10, you're gonna get this dude over here, right? So it's 1000. Yeah, it's quite straightforward. However, if you want to translate back, for base 10 is like that lah, okay? So for base 2 is a binary. So for this one is actually, maybe I should write down. There'll be a 5 twos over here, right? If you still remember. Okay, the power of them are different. Okay, 0, 1, 2, 3, 4, 5. So if this is if this is 1, this means that there'll be a 1 value. Okay? So this will be 1. If this is 1, this means this is 2. Right? If this is 0, definitely this is 0 lah. If this is 0, this is also 0. Okay, I hope I get what I mean. I hope you get what I mean. So this is 1, and then this will be 0. Right? What am I talking? If this is 1, okay, this is 4. 2 times 2 equals to 4. So there will be 1 and 0. Okay, in other words, there will be 1 and 0. If this is 0 means off, this is on. So if this is on, then because 2 to the power of 0 is actually 1, right? So if this is 1, then 2 to the power of 1 is actually 2. If this is 1 also, this is 2 to the power of 2 is 4. And if this is off, in this case 0, then you just off lah, 0 only, that's all. And this is off. Okay, if you put 0, this means off ma, so you have another 0, so you have 4, 2, 1. So 4, 2, 1 means that 4 plus 2 plus 1 is equals to 7. That's all. Okay, so you can get your values. So what is this value? This value is just some arbitrary values, okay, for other arbitrary applications, for random applications or whatever. So this is the case. So if you were to apply into this form, so if it's 0, let's say 1, 1, 0, 1, 0. Okay, 1, 1, 0, 1, 0. What do we have? Okay, 1, 1, 0, 1, 0. Okay, if you remember our coding, okay, this is on. I mean, if 0 is off, then this is definitely 0. And if it's 1, it means on, so there will be 2, right? 2 to the power of 1 is 2. And since this is off again, this signal is off, so it's 0. And this signal is on, is 8. 2 to the power of cube is 8. And then this is also on, so it's 16. So if you add up them together, okay, 16 plus 8, if you sum it out, it's 26 lah, okay. So if you do double check, we will have a 26 things over here, right? So this is how it works. Okay, so decimal place is the different thing, okay. Decimal is in terms of 10, okay. 10 to the power of cube, 10 to the power of square, 10 to the power of 1, 10 to the power of 0. Okay, so it is how many square you want, because this is in terms of 2 to the power of 4 to the power of 3, right? But for base 10 means that this is to be 10 to the power of 5, 10 to the power of 4, 10 to the power of 3, 10 to the power of 2, and 10 to the power of 1, right? So in this case, you can re-represent your systems in this manner, which is much neater lah. Okay, so I think in the question they will ask you to change from binary to decimal or decimal to binary, so you have to be careful about that. So yeah, if you have time, you go and check it out. And then so what is the largest that can be represented in these things? The largest is actually 5 digits, so 10 to the power of 5. Okay, so for base 2 it will be 8 bits. So this is 5 bits, I think. 5 bits for the 10 base 10, okay, and then maximum 8 bits for base 2. Okay, these are the things that you may need to understand. So the highest value is 256. For the 5 digits, it's actually 100,000. And then MSB is called most significant binary. So it is significant means that the largest in a sense. So 128. So this is the largest among them. So yeah, whatever. So I think so. Yeah. So yeah. So let us go to digital to analog. circuit. Okay, digital to analog circuit is actually connecting all the resistors in parallel, and then you connect it to the inverting input. Okay, so this whole thing, as you can see, what is this? This is actually inverting amplifier. Okay, because you're connecting your input into here, while this is actually 0 volts. So this is actually an inverting system. Okay, so if you're doing DAC, you are connecting things into the inverting circuit, and then you have a 3 resistors over here. And then if you want to have a range of things that you can, if you want to input the bits, the binary thing, what you can do is actually alter the R resistance, 2R, 4R, 8R, 6R. So each of the R signifies the 2's over here. If it's 2 to the 0 is actually 1R. Okay, if it's 2 to the power of 1 is actually 2R. And 2 to the power of 2 is actually 4R. So on and so forth. So you have a chunk of parallel resistors connected in parallel and connected as an input into the inverting amplifier. So one thing you need to take note is that there are different voltages over here. There are different voltages. Okay, V1 is not V2, V2 is not V3. They are all different voltages. Okay, so when you add them up together, you have you're actually adding up them together over at this summing point over here, right? So why is it 0 volt again? I'm lazy to think of it, but just let you know that these are all different voltages, and then their output will be the summation of them. Since this is a inverting, okay, inverting means you connect into the negative side, so you have a negative output. Okay. So similarly, if you have R, 2R, 4R, V equals to IR, right? So V is equals to IR. So V is equals to IR. Assuming that I1, I2, I3 they are all the same I's, although they are not the same in parallel. Okay, they should be adding up together. But for simplicity, assuming that this I for all cases are the same, so is V equals to R. Okay, so take note again, this I in parallel circuit should not be the same. Okay, I1 and it should not be equals to I2 or I3 in this case. But however, what they actually set for simplicity, that's why they put it I1 is equals to I2 equals to I3. With this thing, then you can have this assumption V equals to R. Okay, so if V equals to R, then if V equals to 2R, then it will be V over 2 equals to R. So this is why you have V1 plus V2 over 2, V3 over 4, so on and so forth. Okay, so be very careful of the thing in there. So when you are trying to, and what are the things that I can salvage from here? The current are different, so you have to add them up together at this place. So take note that voltage is not the same, current is not the same. Okay, and if you want to have more beats, okay, you can actually put in all these more resistors over here. Okay, so these resistors are connected in this area, and then you can all sum it up into here, and then you put it into the inverting side. So this is an inverting amplifier. Okay, so sometimes it's easier to achieve this ratio because 2, 4, 8, 16. You can either way. What you can do is actually to use same amount of R, but they are connected in series. So this is 2R, 4R, and such. And nonetheless, they are all the same. Okay, they are all the same. There's no difference at all. Okay, there's no differences at all. Okay, and so in test, they may actually ask you to draw an equivalent circuit. What is another method to draw this thing, so you can actually draw in terms of this. But what I want you to take note home is this, that the DAC is connected into the inverting side. You have a closed loop system, and the positive is grounded, and it's 0 volt. Okay, it's 0 volt. There is no input at all. So with this said, I have completed the DAC chart. So in the next video, I'll talk about ADC. So I'll see you there.